Hello everyone, am I audible?
Yes, ma'am.
It seems like you people are came first time. So how many of you are coming first time today?
Ma'am, can you repeat what you said? Like,
How many of you are coming first time? Okay, okay, two of you. So last time I have skipped two classes in my session. So to compensate that, we will do 2 hour class on Friday, 20th January. So you are open to ask any question you have in electromagnetic theory as well as in classical mechanics. So you can post your question on Telegram channel and I will go through them before taking the classes so that uh, it will be good. Someone want to ask something?
Ma'am, channel link
For
Telegram.
the Telegram channel.
Ah,
So anyone from the channel can post the link in the chat.
actually
It
I
will be good.
missed it.
Okay. So there are some people from the channel. They can
Okay, ma'am.
share the link in the chat so you can join.
Okay, thank you, ma'am.
Okay. Okay. Today we are going to discuss moment of inertia, and basically we are going to discuss about the tensor, a moment of inertia tensor, and it's a part of classical mechanics. So let's start with the today's talk. So till now, you are familiar with this linear motion in which you have a particle of mass m and it is moving with some velocity, and you can apply Newton's law directly onto this kind of system. So this will correspond to the case of linear motions. And if there are certain motion forces also on your particle, like frictional force, you can also compensate for that in that kind of motion. But in case of rotational motion, all the terminology that you have used in linear motion can transfer to a different names, like mass is transferred to moment of inertia and velocity changes to angular velocity, acceleration to angular acceleration, and force to torque. So basically, we are kind of looking for a system like you have a particle and it is kind of rotating around some axis. So that kind of motion we are going to discuss today. But before going into that, we will discuss about rigid body. See, in case of linear motion, you have just one mass. And if you apply some force, that all the particles within that mass will move the same velocity in the same direction. But in case of rigid body, if you have lots of masses, then depending on, like, if you have this particle, it will move with certain a circular motion with different radius compared to this particle which is moving with bigger radius. So your different particles, even though they are moving with same angular velocity, but overall motions are different for each individual particle. So in case of rotational motion, to describe the motion as a system, we will use the concept of rigid body. And in rigid body, we means we have a large number of particles and they are at a certain distances which are fixed. And we are describe these particles by their positions and orientation. So basically, whenever we talk about the rotations, we are always going to talk about with respect to some reference frame, which has some origin and all the axes are described using this reference frame. And in case, as I have said, of translation motion, force could be on a one single particle, but in case of rotation motion, we have a, for example, large number of particles. They are moving with different velocities. Linear velocity might be different, but angular velocities are same. So as to describe the motion completely, For all these particles, what we use is the concept of center of mass. So for all these masses, we calculate where all the center of mass of this body is lying. And if we apply the force, that force will be act on the center of mass. And if we're talking about the motions of these, we are talking about the motion of the center of mass. And another concept is the moment of inertia. And moment of inertia means you have some distribution of masses. There might be case like some masses are here, like we have four particles together here, two particles here, which combine together form a complete rigid body. So how the mass is distributed inside this body, this is described by this moment of inertia. So when we are talking about the rotations of a rigid body, we will take into account these things by taking the concept of center of mass and moment of inertia. So, for example, if you have three masses like M1, M2, M3, and they are at a distance of R1, R2, R3 from the origin, we can calculate the total mass by taking sum of all these masses, and the position of center of mass with respect to this origin can be calculated using this formula. I think this you are familiar with in your 12th standard quiz. So center of mass will tell you collectively where is the whole mass is residing. It may be like somewhere here the total center of mass of your body. So if you apply some force onto that, that will act on the center of mass. And if there is no force, that means it will remain at rest or at uniform motion. So the Newton's law of motions will acting on the center of mass. So there is one more concept that we will talk a lot in moment of inertia is the principal axis. So principal axis is the axis which is passing through the center of mass of your body. So whenever we talk about the principal axis, it is an axis that is passes through the center of mass of your body. And we will see that the moment of inertia that you have calculated in your 12th standard, all those moment of inertia are about the principal axis. And I think you have used these two theorem as well, the theorem of parallel axis and the theorem of perpendicular axis, in which you know the moment of inertia about the center of mass axis, but you wanted to calculate the moment of inertia about some other axis. So you will use the concept of parallel axis theorem or the concept of perpendicular axis theorem. That thing we will not use today, since we will find a general system by using that these will become automatically calculated. So that we will see here. So we are not going to use this theorem to calculate our moment of inertia. So for example, if you have a rigid body and you have a fixed axis which is like perpendicular to this plane of paper, and you have a mass m1 which is moving with velocity v1, and r is the perpendicular distance of this mass from this axis. So you can calculate your velocity by this formula omega vector cross r. Omega is your angular velocity. So in rotational motions, your angular velocity for all particle is going to be same, but your linear velocity might be different. So it is good if we can write the kinetic energy in terms of angular velocity instead of taking individual velocity of the particle. So this will help you, to reduce the number of unknown in your equations. So for example, if you wanted to write the kinetic energy of your system, you take one mass and one p1 square. So you just take the kinetic energy of whole masses and then you just sum them up. Or you can change your velocity by taking this formula omega cross r, since omega and r is perpendicular distance. Your omega is in the plane along this axis. So this velocity will become omega r, sine theta will become 1. So you just replace it here. So your kinetic energy will turns out in, since omega is same for all the particles. So you can take omega outside. So your kinetic energy will become 1 by 2 omega square, and this term which we known as the moment of inertia. So you can write your kinetic energy as 1 by 2 I omega square. So your I is the moment of inertia that will decide how is the mass is distributed within this a rigid body. So your kinetic energy therefore depend on the distribution of masses within that body. If your mass is distributed more closely toward your, if you have two system in which your mass is most closely distributed near to this center of axis, and you have another system in which mass is distributed away from the uh, your axis, the center of mass axis. So what do you think in which case kinetic energy is going to be more? Since your moment of inertia is given by I equals to mr square. For a general case I am talking about, r is the distance of this mass from your center of mass axis. So your distance will decide how much moment of inertia you are going to have. So in this case, since r is much larger compared to this case, so this system have much higher kinetic energy compared to this system. So your kinetic energy will depend upon how the mass is distributed around your center of axis. And the moment of inertia is the quantity that will decide how the mass is going to distribute. There are some cases in which mass is not, for example, you have a continuous distribution of mass. Instead of having M1, M2, M3, you have some continuous distribution case. So like this, there is body and you have some mass distributed. So in that case, since your density is going to be constant, so you just replace your dm quantity with this density. So you just replace dm by rho dv inside this formula, and the summation is replaced by the integral. So this is the formula for calculating moment of inertia in continuous case, and we will see later how we are going to use this formula. And also we can calculate the angular momentum of the rotating body, since like angular velocity and the linear velocity v is related by the angular velocity as r cross omega, I guess, r vector cross omega. V is given by omega vector cross r. Similarly, here the angular momentum is related to the linear momentum by this relation that it is given by r cross p. P is the linear momentum. So I have just talking about the magnitude part of this angular momentum, which is given by mv into r. So for n number of particle, it will become mv square. Since omega is constant, it comes out of integral. So you can also write your angular momentum in terms of moment of inertia. So if you have large number of particle like m1, m2, m3, and they can have different linear velocity, overall angular velocity of these particles are same. So each of these particle is kind of going to have a circular motion around the axis which is passing through the center of mass. So we can always write our angular momentum like r cross p, or for large number of particles we can sum over the angular momentum of individual particles like we have done for the kinetic energy case. And since we can write vi as omega cross ri, so just to reduce the number of unknown variable in our equation, and you can see that it's a vector triple product. So when you solve the vector triple product, I think you are familiar with that. If you have vector triple product, it's just A dot C and B outside minus A dot B and C outside. So this is just solving this equation by vector triple product. So you have this equation in vector form. So we are trying to write moment of inertia tensor using this equation. So what you can do is you can take all the components separately. You have L vector, we can write it as x component, y component, z component. Similarly, the position vector r can also written in terms of x, y, and z, and angular velocities also can be written in x, y, z coordinate. So if you look at this quantity ri dot ri, that means x is multiplied by x, y is multiplied by y, and z is multiplied by z. So if you can do this dot product by yourself, you can see that this dot product will going to give you multiply with the same quantity. So you get xi square plus yi square plus zi square. So this is just ri dot ri. Similarly, if you do ri dot w, this is your quantity. And you can now equate the x component with the x component and y component with the y component. So this is a scalar. This is also a scalar. This is the vector quantity, omega vector, and this is vector. So if you wanted to write this quantity will turns out outside and omega x plus I in the I cap plus omega y in the j cap plus omega z in the k cap. This quantity is going to multiply with everything of this. So instead of solving, multiplying every component and then combine everything, what we do is just take focus on x component. So you take x component omega x multiply by this. Since summation over mi's will remain as it is, you have to sum over n number of particles. Similarly, here this is constant, so you can take as it is, but Ri will become Xi only if I am focusing on one component. And then that Xi is going to multiply with every one of these terms. And now you can just see these two terms are matching, so you can just cancel out this term. So only x component of your angular momentum will become this. You can do this calculation by yourself. You are ended up with the same expression that I have shown you here. Similarly, if you write for y component, it is the y square term which is going to cancel out. And in this term, you are left with xi and zi. And these are the terms that are left with y. Similarly, you can do with z component. I hope you are getting how I'm computing this x, y, and z component. So if you are not comfortable with this, let me know. So you can write since L vector as I into omega. Sorry. So since L have x, y, and z component, you can see in this equation, you have omega x multiply here, omega x multiply here, and omega x multiply here. So all these terms, like if you do multiplication, hmm, how you can do matrix multiplication? You take this row and you take this column. So in column, if you have omega x, so your first row will multiply by first column if you wanted to calculate Lx. So all those terms which are omega x will lie in this first row. So you can see this is your omega x term. I just write it outside the integral, outside this matrix. And here this one is omega y. So you have this term multiplied by omega x plus this term multiplied by omega y plus this term multiplied by omega z. So if you can see that the Lx component will become this term multiplied by omega x plus this term multiplied by omega y plus this term multiplied by omega z. So you can see I have just written on these 1, 2, 3 equation in the form of matrix. And you can see that these kind of expression represent the inertia. So these are known as Ixx. I have just write it as a notation. And this is Ixy and Ixz. And when you write this term, this whole tense matrix is known as moment of inertia tensor, and it will contain the moment of inertia about different axes and how the mass is distributed. So this is the matrix. So it is going to follow all the properties of a matrix. It is a symmetric matrix. If you can see, this xy component is same as yx component here. So it's a symmetric matrix. Ixz is same as Izx and Izy is same as Iyz. And this diagonal is term is related to Yizi square, these terms. So if you calculate the eigenvalue and eigenvector of this matrix, you will get the principal axis that is passes through center of mass. And eigenvector will give you the principal axis, and eigenvalue will give you the principal moment of inertia. And you can, I think you know how to calculate the eigenvalue and eigenvector. And by using that, you can also diagonalize this matrix. See, if you are ended up having a matrix which have only diagonal elements, all other elements are zero, in that case, moment of your angular momentum L has same the direction of angular velocity. Otherwise, the angular velocity direction is different from angular vector because of this tangential nature. And if you wanted to calculate moment of inertia about any other direction other than principal axis, you can just use project your direction onto that principal direction, or you can use direct this formula. You calculate your moment of inertia tensor, multiply your direction, and it's simple matrix multiplication. And this formula is coming from this projection. So it's a matrix multiplication. For example, you know your matrix I is 3 cross 3 tensor. So for example, if you have a cube and for that case you wanted to calculate moment of inertia about any other direction, like some any other direction. And I think you know how to write the equation of a line in a certain direction. For example, I just write it the coordinate in x, y, and z. It's a vector. I think you know how to write this in vector form. So you just take this and write like I plus j plus k and multiply your 3 cross 3 matrix with multiply 1 1 1 and then multiply 1 1 1 like this. Then you can calculate. This will give you the moment of inertia about any other direction. So whatever the direction you have asked in exam, they will give you the coordinate along this direction. So you can directly use this formula to calculate the moment of inertia. So these terms which are lying along the diagonal of this moment of inertia tensor, they are known as moment of inertia, and the off diagonal terms are known as the product of inertia, and they are symmetric. And in continuous case, instead of having summation, we can just replace it with integration and small element dm. And as we have seen earlier, we can always take our density as constant. So dm can be replaced by rho dv. And if you have done this in electrostatic course as well, the dv can be written as dxyz in Cartesian coordinate, and this is given by volume element in spherical coordinate, and this is volume element in cylindrical. Similarly, you can also have the mass distribution in surface instead of volume, or you can have the mass distribution in case of line. So the calculation will be very much like that you do in case of electrostatic, where charge is distributed on different surfaces. So from that analogy, you can calculate the dA and dl vector as well. For example, this was the question from GATE 2018 exam. And in this question, it is given that a uniform circular disk of mass m and radius r is rotating with angular speed omega about an axis passing through its center and making an angle theta. This is 30 degree with the axis of the disk. If the kinetic energy of the disk is alpha omega square r square, what is the value of this alpha? So you have to calculate what is the kinetic energy of this disk which is rotating at an angle 30 degree. So kinetic energy can be written for a rigid body like 1 by 2 I omega square. This quantity can also be written in vector form by using angular momentum, since L is given by I omega. So we can always write our kinetic energy like this. And since dot product can be written like in terms of cos theta by taking magnitude. So theta is given as 30 degree. So you just put it here. So this is your kinetic energy. Now you know that this I is the moment of inertia of the disk about its axis. and it is given by 1 by 2 r square. We will see how to calculate it later. So your kinetic energy will become square root of 3 by 8 mr square. So this will become the value of your alpha if you compare it with this expression. So your alpha will become 0.21. Now the question is how we will calculate the moment of inertia of a disk about its axis. So there is one formalism that you have learned in your class, and if you use this one formula, it is valid for all the cases. This formula. So you can use it for calculating the tensor as well as for any other case. All you have to do is first write I as integration of dm into r square. Then you have to see how much the r distance is from your axis of rotation. So here, this is my r. So I just take an dm element here at a r distance, and we know that it make like if I have a disk and I can take a dm element here, it will make an angle d theta at a distance r. So your total element will become r d theta. This is the area, small element area. So since sigma is the area element which is given by dm by dA, and as I have told you here, so sigma is given by dm by dA. So you can always write the d as this is your surface charge density. It is going to constant. So if you have a small dm element within an area dA, it is equivalent to having like total mass m divided in a total area pi r square. So these two quantity always going to be equal. So from that you can always calculate dm as m by pi r square into dA, and you know that your dA is given by r dr d theta. So this is your dA element, surface element. So you just replace dA with the surface element r dr d theta, and dm is whole replaced by this m by pi square. Pi r square. So whenever you encounter this kind of situation, first write the moment of inertia in this form, equate these two expressions like total divided by total area or total volume, and just calculate dm in terms of dA or dV or dl, and then just integrate these expressions. R can take value from 0 to capital R, theta can take values from 0 to 2 pi. So when you integrate this expression, and you are ended up having moment of inertia of your system. So all the problems can be solved by using this simple analogy. For example, this is the case for moment of inertia of a cube, and now we wanted to calculate the complete moment of inertia tensor. Like we wanted to calculate all the elements Ixx, Iyy, these terms. So let's first focus on one element Ixx. It is given by dm pi square z square. Now again we have to write dm by dV since it is a volume. So this is the whole cube. So total mass of your cube divided by total volume of your cube. So these quantity are kind of constant. So you can always write your dm in terms of dV. And dV in Cartesian coordinate system is given by dx into dy into dz. So when you put your dm multiply by y square plus z square. So you just integrate these expressions and you can calculate your moment of inertia tensor one element Ixx. And since it's a cube, it has symmetry. Whether you calculate about this axis or this axis, it is kind of having symmetry. So your Iyy, Izz are going to be same. So now calculate the off axis element Ixy. So Ixy same as Iyx, and it is given by minus integral of dmxy. Now again we know we can write our dm like m by d cube dx dy dz. So we have to integrate just x and y component here, and that will give you ixy or iyx. Similarly, we can also calculate ixz, and since it is a symmetry, so they are all going to be same. You can verify this that ixz Iyxy is same as Iyz. And this is here just because of symmetry. For other system, you have to calculate them separately. So when you put all these value inside this expression of moment of inertia tensor, and I have just taken, since it is 2 by 3, it is 1 by 4. So I just take mv square by 12 as the outside. So this is your moment of inertia tensor. So as you know, it's a 3 by 3 matrix. So you can now calculate its eigenvalues and eigenvector to calculate where is the center of mass axis, the principal axis of your system is lying in this case, and what is the moment of inertia. So if you calculate the eigenvector and eigenvalues for this matrix, so eigenvalue will give you the moment of inertia about your principal axis. Eigenvector will give you the direction of this axis, in which direction it is going to be. So you can verify yourself that if you calculate this, then the principal axis is going to be one which is through the main diagonal of your cube along this one axis. So you can, one of your vector, eigenvector is going to be like this one. So you can verify this by yourself by calculating eigenvalue and eigenvector. I think you know how to calculate that. And there is one more type of question that was appear in GATE exam, and this was from GATE 2017. A uniform cylinder is released on a horizontal surface with a speed of 5 meter per second without any rotation. So it's a slipping without rolling. Means you have this cylinder and it is slipping. It is not rotating, rolling. The cylinder eventually start rolling without slipping. Now at certain distance, it will stop and it will start rolling like this kind of motion. Now it is not slipping. Now, if the mass and the radius of the cylinder are 10 gram and 1 centimeter respectively, what is the final linear velocity of the cylinder is? So this kind of question always appear in GATE exam. So whenever you have asked this, that your cylinder or your wheel is kind of moving without slipping, it is just rolling. So you know that whenever this rolling kind of case appear, your cylinder is rotating with angular velocity omega, but its center of mass is moving with linear velocity v. So in that case, your kinetic energy will be sum of angular velocity, will be sum of the kinetic energy due to angular motion and the due to linear motion. So whenever initial case your body is rolling without sleeping. No, initially your body is sleeping without rolling, so you have just linear motion. There is no rotation. And finally you have both rotation plus linear. So your final kinetic energy will be 1 by 2 I omega squared. This is due to rotation and 1 by 2 mv squared due to linear motion. And one of the important point that you have to note is in that case angular velocity is the direction of omega is perpendicular. You can calculate by right hand rule. Your thumb is the direction of omega. So it is perpendicular to v. So your velocity v which is given by r cross omega. So this r cross will become sine theta. So sine 90 will become 1. So in that case, this formula is always going to valid that your V is equals to R omega. So you can just change your V by R omega. So this will become your kinetic energy. So if you look at I is the moment of inertia about the center of mass, mr square means you have just added this extra. So in that case, your kinetic energy will become 1 by 2 Ia omega square. Ia means you have calculated moment of inertia about this contact point. So if initially your kinetic energy is given by linear motion only, which is 1 by omega mv square, since there is only slipping, no rolling. Finally, you have both rolling plus slipping. So this omega is now just replaced by this relation v by r. So we have to calculate what is the final velocity we see in this case. And I just put The moment of inertia of a cylinder about the center is just like a disk. So it is 1 by 2 mr square. Just sum this up and calculate the VC. It will become 2/3 of V. So this will be your linear velocity or final linear velocity of the cylinder. So if that kind of question appear in exam, just remember that this formula is valid here. Otherwise, you can calculate all the moment of inertia tensors. So with that, we will finish today's class. If you have any doubt, you can ask. And we have this announcement that on 20th January, we have 2 hour class from 6 to 8. And you can post your question on Telegram channel. So anyone from the Telegram channel, please post the link for joining. Other people also want to join the channel as well. Yeah, I'm asking from other people. There are a lot of people from that group. Okay, someone has shared the link, so you can join. So if you have any doubt, you can ask. I haven't seen any gate question which are just coming from the tensor part only. Okay, so do you have any doubt? Okay, so whatever your question are, you can post on Telegram channel. We will solve on 20th January. Okay, then we will finish today's class. Bye bye.
Thank you.
Okay.